And so before the break, we took those starter files that were sent out before class and put in a character and a coin in a random spot. The character moves around. It stops on this border. I'll leave it to you all to do the rest of the borders. Be the same logic as we did on the left-hand side there. So no need to spend a whole bunch of class time on that. But the main thing for today is we're talking about our events, and our two primary internal events: clocks, collisions, and timers, or clocks. Some people just like to refer to it that way. You may see some tutorials or reference material or something that just says set a clock. First off, collisions. We want something to happen when these images intersect. And that's one of our key internal events in every game engine. That's how we react to the inputs from the user. So the external events are like pushing the WASD keys. And we run through a selection structure depending on which one was selected. We'll do the same thing with these images. But right now, these are just images. We grabbed an image, stuck it at these XY coordinates. We need the computer to know there is an image there, or we need the computer to know it should care about that image. It needs to care about our player image, but not about our background image. So first thing we have to do is define some sort of boundary, the edge to this. And to start with, I'm just going to use a rectangle. We'll do rectangles around the whole image. So I'll call it bounds. So player bounds. And Pygame has a way that we can grab it. And in fact, it is in this image object that we called the load method for. So once we have an image object here, so we can use this image object to find out where its edges are. So if we ask for that, the player sprite that we loaded an image into, there's other things involved in that image, and we can call this method getRect. And then that'll tell us where the edges of that are. And same thing for the coin. Well, I'll go ahead and finish out player win, then we'll do the coin. Then we'll do the same thing for the coin. But this is the start of the game, right? This rectangle that we've stored in this variable, well, they're different variables, right? Here's our image and here's our bounds. They're stored in different places. They aren't the same thing. So we'll also need some X and Y components for our bounds. And with a rectangle, those are built in. You remember the other day when we were looking at drawing rectangles, we'd give a XY point and then the width and the height. So since we ask for a rectangle here, we have that XY and the width and the height. So we can make a reassignment to those. So that player bounds, we haven't talked about objects, so we'll say variable. The stuff stored in that place, there's a lot of information stored there. It's all the stuff about a rectangle. So we can use the dot operator to access some of that stuff. And then this is what we'll be talking about next Monday, because I don't think we'll get to it today. At least not with sufficient lab time to play around with this stuff once your game's once you have the pieces to make the images fully interact with each other. So we can ask for the X part of that rectangle. And obviously, I want that to line up with this image. So I'll say the player bounds X is going to be set to whatever the player X coordinate is. And same thing for the Y. The player bounds dot Y. So the player bounds data has a Y value already in it. So we're going to use the dot operator to access that stuff that's in the data already. So the dot Y, and we'll just assign that to match the player Y component. So that way we have a rectangle. We have the boundary of our player image defined as a rectangle that surrounds the whole thing, and then it's at the same spot. And we need to do the same thing for the coin. So I'll call it coin boundary is, well, we can just surround that image. So that pygame.image thing that we loaded in, we'll ask for that, and we'll get the rectangle of that. And then I'm going to make a type. I just realized I'm going to make a typo of doing boundary, but I'll try it. So coin boundary dot X will be the coin X, and coin boundary dot Y is the coin Y. So I went ahead and I realized something and thought I'd go ahead and leave it here for an example, because there's a really good chance a typo is going to happen here very shortly. Does anybody have a thought of why I suddenly expect typos to happen when I go working with these? You see anything about those edges we assigned that might cause a problem? Anything in the chat room? No thoughts on it? What I noticed is I called this one bounds, and I called this one boundary, which means that I have to remember two separate things when I get down there later. A much better form would have been to call them both bounds. But I'm going to leave it like this now, expecting a typo, and we can easily fix typos. Right? Y'all even know what sort of error message that's going to throw when that happens. But I'll leave it here for class examples so you can see that happen. But for good form, it'd be a lot easier to keep track of which one's which if I called them the same thing. I noticed it, but I'll just leave it here and let the error happen in the example. So help you all remember how to avoid them or detect how to avoid them. So now we have some bounds. And if we come over and run our game, we won't see anything yet. It doesn't look any different. Character moves around, doesn't behave any different. So the bounds or the edges of these images is internal data. We don't see anything. But a lot of times for debugging, we probably want to see it, right? So I'm going to come down here, way down at the bottom of the main loop, and I'm going to go ahead and draw those rectangles. We saw that the other day, so we have that pygame.draw.rect method. I think it was a lowercase r here, that draws a rectangle, and then we have to pass in a couple arguments. What are we going to draw on? Well, we'll draw on that thing we called scene, the display object. And what color do we want it? I'll just go with a light gray. And remember, if our RGB values are all the same, that's the grayscale. And all zeros is black and all ones is white, which we're using decimal numbers. So all ones is 255, 255, 255 is white. So if we're closer to the 255 side, it should be a light gray rectangle. And then what rectangle do we want to draw? The other day we had to define a new one. We said, okay, use a pygame.rect, and it drew that. But we already have the rectangle we want to draw right up here. Where was that? Like, oh, there it is. So instead of having to ask for a new rectangle, I can just ask for, say, player bounds. And same thing for the second one. So I'll just copy that line, paste it in here, and instead of drawing player bounds, I'll draw coin bounds. Boundary. Almost made that typo already. See, whenever it's a little change, both words make sense. Being consistent on things like that can make a difference. So I think I am going to go ahead and rename it bounds, just for consistency. Y'all saw the very first time I went to type it, I put the S there and then quickly caught myself. And it's a class example, so I'm talking the whole time I'm typing. So just another thing to keep in mind is be consistent in your naming. It makes it easier to remember what's what, because now everything's just bounds and I just have to think about whether I want the player or the coin one. I'll draw that. Now we can see it drew that rectangle in, which is obviously right on top of our images, so we can see them. If you wanted it behind the images, you could put it behind them. I cut from there and put it before, after the background and before the coin and player are drawn. Then it'll draw those rectangles first and then draw the images in front of them. So you kind of have an option there. You can see where, kind of see how they look next to the images and things. But at some point when debugging, you're probably going to want to see them. I'm going to move them back down to the bottom to express that point that the computer doesn't care what image we ask it to show. It's like we said to put in an image, and these keys do something with one of them. That might be a problem though, right? Our coin hasn't moved yet, but our player's not next to our bounds anymore. So we better go address that. But at some point, you'll probably want to see them to see what's going on. Does anybody have a thought on what we need to do here so that the player doesn't leave the boundary we defined for him? Here's where our image moves, right? So it probably needs to be somewhere around here. We could just adjust the boundary X and Y every time, or we could do it all at once. So kind of an option. You could come in here and say like player bounds dot Y minus equals player speed, and do that on each one. Or we could, what I like to do is come down after the player moves and then reset them the same way we did above. So like player bounds dot X, we'll assign that the player X value, and player bounds dot Y is assigned the player Y value. So that way, by the time we do event check it external events first, so by the time we're drawing stuff, the boundary and the image should be in the same spot. So if we run that, now it kind of moves around. And that rectangle behaves the same, right? I've heard some people say that it's really good to start out and get as much of your script debugged as possible with just a plain rectangle. I like to use scratch images so that I can kind of get more of a sense of what it's going to look like afterwards. But I've heard some people say that a plain rectangle is great for getting the script together, and then you put the image you want in later. Whichever way you feel most comfortable with, maybe try both ways on small things to see which one you like better. But that point I expressed earlier, it's kind of like the magician waving their hand, right? The old trick of there's nothing up my sleeve, and they'll show you their left sleeve while their right hand does all kinds of stuff. So you don't notice what the right hand's doing while they're showing you their left. There's nothing hidden in their left sleeve. It's like that. The animation is a little bit of waving that catches your attention, and then other bugs going on in the game go unnoticed. So a lot of times it's important to have still images for debugging your code. It'd be very beneficial. That way the bugs don't explode on you later. And now that we know where those are, I'm going to comment these lines out because I don't necessarily want to see those boxes, but at some point in the debugging process, there's a good chance I might need to see them or confirm where things are, or if things aren't. If they didn't load in the right spot, I want to make sure that I can figure out why. So it's a good idea to always have a way to see them, as well as to see them or not see them, so you can make sure that your collisions are going to happen correctly. Like get your collisions debugged properly, because that is one of the biggest, our main events, right? And we want something like, we want the character to pick up the coin from here. If I really, this is a quick example, so we're just going to use that whole image, but not red, there's red on there. I use black. In a situation like this, with a character picking up coins, I would restrict it to like that sort of boundary. So the coins can only be picked up if it's like there where his hand would be grabbing them, which is just a smaller rectangle. And we did see how to draw rectangles. I'll leave that in a comment for when I send these out. So here, alternate, we could just say player bounds equals a pygame rect. I think this one has a capital R, doesn't it? Do I have the example from the other day? Nope, I already deleted the example from the other day. It might be a lowercase r there. Pygame is very inconsistent about the capital letters and underscores and the cases that's used. It's an open source project, so multiple people have worked on it and developed it, but nobody has spent a tremendous amount of time cleaning it up, so it's inconsistent. That might be a lowercase r. It'll match the example from Monday. You can see what not the pygame.draw.rect, but there's also a pygame.rect, where we feed in an x value, a y value, a width, and a height we want. So for like a smaller one, we might say something like, I'll leave that there for reference material. I'll do something else here. I can't remember if it's uppercase or lowercase right now, and it's in Monday's example, so you can check it there. You might say it was something like player X plus 10 pixels, player Y plus 10 pixels, and I don't know, them 30 wide and 40 tall. That's sort of an arbitrary guess on those numbers. I'm not really going to check them or anything. But then that, instead of doing the whole image, would restrict it to just a part of the image if we wanted to make our collisions more precise. We're going to have lots of lab time today to play around with this because it's an active subject. We learn by doing, and in our case here, doing is a lot of fun. We make a game. We make things happen. In this case, the player's going to pick up coins. So I go through the to-do list. I don't have the links here. I don't have annotations turned on in Notepad++. Oh, a lot of our good text editors also have that annotation stuff built in. I turned it off in Notepad++ because it conflicted with some annotations in C++ was conflicting with something else. So I turned it off and then haven't turned it back on since then. So a problem in a different language is just led over here, but text editors know those too. It's not just the really nice IDEs. That is part of the programming language that goes in the comments instead of the scripts. So it looks like all the to-do list stuff was done except for this right here. Detect collision between player and coin and then do something. So my idea to finish out this example here is sort of a small thing. We'll just simulate picking up the coin. Right? We're not going to, at this point, we're not going to have do an animation of the character bending down and grabbing that coin, sticking it in his pocket. A lot of times in video games, it's an illusion thing. We just need to give something close enough. So if there's a lot of animations going on and the character's arms are waving around and that coin disappears, that's going to look like the character picked it up. So that's often what we're going for, is the illusion of what we want. Not necessarily every single detailed step. If it's enough that the illusion looks right to the player. So we can just make the coin disappear when that happens. And to do this, some of our game engines, the collisions will just be in the overall event list that we check every time through. Here in Pygame, we can check them in live time as we need them. That way they happen immediately when they're detected, and we don't have to wait till the next pass of the main loop to handle the collision stuff. Which is the two main ways they're done, but there's so many game engines. Obviously, that's not the only way they're handled. So in some engines, they're in the event list that we check every pass through our main loop. And in some engines, they're a separate thing so that we can detect collisions whenever we can react to collisions the instant they happen. We don't have to wait the 16 milliseconds till the next pass, moving at 60 frames a second or 140 frames per second. Some are, I think I've heard of games running faster than that as well. I can't remember with the other numbers, but computers can handle a lot more than 60 things in a second. That is mostly to find that middle ground between the high speeds computers would run through the loop and human reaction time. And that's what you would want to look for with the frames per second rate. So we can just check this. We're going to know for a player object, the boundary for it intersected with the boundary for the coin object. So we'll pick one of them. So player bounds. And when I do this for consistency and to make things easier to debug, I usually try to put the one that moves, the one the user's controlling, not really the user, the one that we would think about that happening. So in the case of a mob, combated enemy, did the player collide with the opponent, or did the opponent collide with the player? So we have to pick one of those game objects that's actually which one's going to check for the collision. It ultimately doesn't necessarily matter, but if we're consistent in how we do it, like I like to do it the way I think about it. The way I think about it is the player hit, in this case, the player hit the coin, or did the coin hit the player? Just for consistency to help with debugging. So if player bounds dot collide rect, which once again, juxtaposition notation this time. So no camel case, no underscores, no Pascal case. We've seen lots and lots of different ways of putting our variables together in Pygame. So Pygame kind of has all sorts of them, but our keyword is collide rect. And then the argument for that collide rect method is, what are we wondering if it collided with? In this case, the coin bounds. Oops. So did the player bounds intersect our coin bounds? And those who had me in programming classes before probably heard me say that when putting conditions together for planning and debugging, I like to put think of the word is there. So we're asking the question, is player bounds intersecting our coin bounds? I know reading that out like that probably seemed very trivial in this first example, but the collisions will get much more complicated as your games get more interesting. So I wanted to take it nice and slow and build a good solid foundation, and hopefully you have a good understanding of everything that's going on in a collision and where it's coming from and how we're dealing with it, and not just that one word to type in. Although really, the one word to type in is what we need. And then making more games is going to build the experience. So if that happens, what do we want to do? We want the coin to disappear. I guess reappear somewhere else, right? Coin to reappear and add to our score. I think that's everything we need to do. Just make the coin disappear from where it was, reappear somewhere else on the screen, and then we'll add to our score. So disappear and reappear is easy, because we can do the same thing we did when we started the coin. We set it at some random variable, and then make sure our bounds are set to the same place as the image. I'm coming here and copy those. So the coin to disappear is essentially, we'll just give it different coordinates. Home key and tab over there, in key. And then coin bounds x is assigned the same thing as the coin x, coin image x, and the coin bounds y is the coin y. And there's kind of some information in that assignment we just had to do, right? That means the edges and the boundaries that we define for the coin do not have to be beside the coin image. They could be on opposite sides of the screen. That's probably going to happen a lot with NPCs, right? Might not necessarily want to walk all the way up to the NPC to do stuff. You want that, like when your character enters the local town and some panicking villager sees the hero in the story, they come running over. So the collider for the particular NPC that's in the panic and going to run up to the hero of the video game is probably going to be by the town entrance, while the image is just wandering around randomly on a timer until that collision happens and then runs over to the player. So they do not have to be in the same spot. That's why we have to make this assignment here if they are going to be in the same spot. Then coin to reappear, well, that's just drawing it. We have that right up here. So I'll copy this line, change our X and Y so it disappears from where it was, reappears in the new spot, and add to our score. I think I made a score variable. Yes, so I have this variable called score. So I'll increment that. So if we picked up a coin, then score addition assignment by 1. There's an else part we need, but I'm going to go ahead and show what goes wrong with what's here. So there's a slight problem here we'll need to adjust, but I want to show you what it looks like so you'll know how to spot it. So it's like, okay, yep, that's everything I thought about. It should be ready to go. Come over and run the game. Oh, it's not doing it. Okay, it's not showing the error I was expecting. What's in the wrong order there? Maybe this needs to be afterwards. I'm going to make all those adjustments and then do this. Let me take this line out and see if this is the error I was thinking about. Well, but when I was getting ready, I threw that error like 3 different ways. Sometimes this coin will just bounce around all over the place. Like something would go wrong with the collision and it would trigger that collision every time. So on every frame, the coin's bouncing around the place. If you see that happen, what you want to do is draw the coin with an if-else structure. So in this line here, for the general drawing the coin, our basic drawing the coin where it was the last pass through the main loop on the last frame of the game over and over again. That happens whenever we don't have a collision. And then the collision does something different. But it's not throwing the error it's not throwing the error I was expecting to throw, and that shouldn't be too big of a deal. In general, this is a better way to do it. So just take note that it's better to do those collisions as an if else and put your default in the appropriate spot. Whether you're normal drawing the coin into an if else structure with the collision instead of separate from it. Because it causes a bouncing error. The coin just bounces all over the screen, disappears and reappears in random spots, and we kind of lose control of it. But it's better to do it that way anyway, so I'll just say it that way. So there's our coins over there. Our player can approach the coin, pick it up. Another coin appears, approach it, pick it up. Another one, and it just kind of runs forever. Excuse me. So that is our first look at the primary internal event for controlling video games is collisions. Went very, very slow. There's more than just taking 3 seconds to say, type this word. Hopefully help build a nice solid foundation for, in the long run, a nice complete understanding of what collisions do and how to work with them. We will come back and revisit them more later. For now, I'm just going to kind of finish this out. Then we collided with that. We incremented our scores, so the person playing the game probably wants to see the score, right? And that's like we saw the other day. So I'm going to make something called show score, which will use that way up here. There, I initialized fonts and created something called score font with Times New Roman font, because that's in so many standards that it seems like a safe bet that Times New Roman will be on somebody's computer or on everybody's computer. And then the size of it. I'm going to start the variable at 0. So I'll use that to create something. Our show score variable is going to hold something created from that score font. And we're going to render it. And then we saw the arguments we need the other day. So first off is, what do we want to render into that font? What string do we want to enter? Our score, which is an integer. What needs to happen to that score in order to print it out? Anybody remember the Python stuff for that?
Got to set as a string.
Yes, because Python is open typed, which means we don't have to say what we have, but once the computer figures out what we have to stick with it. So once the computer figures out we have to have an integer, we can't suddenly use that integer as a string. So we do still have to do casting. That's an easy one to forget in open type languages. And then we have anti-aliasing, which you should avoid unless you absolutely need it. It's very hardware heavy. It will slow everything else down. And that is smoothing out jagged edges, smoothing out pixelation in software. For one, there's only so much we can do. Screens are built up of square pixels, so everything on the screen is going to be pixelated. Screens are much nicer than they used to be, so we have so pixels have gotten smaller and smaller and smaller, so it's harder to see that pixelation. But hardware solutions for pixelated images are kind of expensive, so we do have software solutions, but try to avoid them until you need it, because it is very resource heavy and it will slow everything else down. It's called anti-aliasing. And if you do need it, things are too pixelated, just put a true in that spot instead of a false. And then what color do we want to write it in? I'll try something black, so like 23, 23, 23. But they're all the same value. The red, green, and blue have the same value. So that's on our grayscale. And it's much closer to 0, 0, 0 than it is to 255, 255, 255. And then, just like we saw the other day, that's what we want to print on the screen. So it's stored in this variable. And then we have to use our split method to get it onto the screen. So we're going to split that show score thing we just made, which really doing that on a separate line was just to avoid typing all of this inside of this here for the argument. We just gave it a name and then used that name instead of typing all of that right here. Either way works fine. And essentially it's the same thing. We took all of this, stuck it at some spot in RAM, and then on the very next line, we grabbed whatever was in that spot in RAM, is what's happening there. And then where do we want to put it? We need a vector 2. Your reference material will refer to 2D vectors as vector 2s and 3D vectors as vector 3s, is the way that that's typically written in reference material and for most of our game engine stuff. Vector 2 or vector 3, so we're in 2D. We need a vector 2 position for that score. And I'm just going to pick a random spot, maybe the upper right somewhere. So I'm taking, and again, take a guess for a starting point and adjust it. So the drawing area is 840 by 500. So I'll come over maybe 710. That's kind of towards the right somewhere, and down 50. just a guess to start with, and then adjust as needed. 7, 10, 50, and when I see what that looks like, I might come back and adjust it. Which, yeah, I'll explicitly state it again, repeating myself, that just take a guess of a starting point and then adjust it as needed. Same thing for positions and speeds. Oh, we can see our score goes up. We got 2 of them. And the last thing we need is probably an end to the game, right? So we're going to talk about storytelling soon here in class. We want some way to know when things are done. So I'm just going to pick a number. Let's say look like 5 coins. That way we don't spend a long time here collecting coins just to check the example. So once our score is at 5, hits 5, we'll say, okay, yeah, that the game's over. So after showing the score, I'll just check it. If score is greater than 5, or greater than 4, we'll collect 5. So as soon as we hit 5, I'll put a message up there. Victory equals, we already have a font, so I'll just score font, render again, and we'll render, I don't know, victory, success. That's a good word. Say success. That's 5 coins. And what color is it going to be? I'll try white this time. 234, 234, 234. Well, I guess not quite white, but the same way I said black for 23, 23, 23. Those are both grays, but they're way out on that spectrum, close to black and white. And then once we have that message, we'll just blit it onto the screen. Scene.blit, victory, and put that somewhere in the middle. 800 wide, so really the center of the words need to back off a little from the middle. So I'll try 350. 400 would be the middle. So I'll back off a little because I don't know what that string's going to look like. Once again, a guess at a starting point, and I'll adjust it once I see it. And then, how wide was the screen? 540? Is that the number I put in? 500. So the middle is 250. This one I can do the math for because it is a 32 pixels of font. So if the very middle is 250, I want to center that, then that means I'm going to go 16 pixels above it to get the top of the text. So 250 minus 16 would be 224. So that one I don't have to guess. I actually do the math to figure out where the top half of a 32-point font would be on a 500 pixel screen to get the middle right in the middle. So we can give this a test. I'll come over here and run it. Let's see, 1 coin, 2 coins, 3 coins, 4 coins. Well, it kind of worked, but then it crashed. Oh, I forgot the anti-aliasing. So you'll see there's a type error. I asked for a function, so in the line it pointed at, they're on line 90, score font, but there's a function, have a name and then parentheses and some arguments passed in. That's our syntax for a function in Python. The function it recognized needs 3 arguments and I only gave it 2. I forgot about the anti-aliasing. Oops, Python, so capital F on false. Now let's give that another try. All right, so that worked. Anybody have any questions about that? There's still a little ways to go on it, right? Not quite a complete game, but we have our character moving around, doing something. There's a score that's kept when things happen, and finally a message. But there's still some other stuff, right? Like we could stop playing when that happens, because the message is already there, but the character can still collect coins. There's these only restricted our game space or our play space, or our game space is only restricted on one side, but the logic for that would follow suit. So there's still a couple things to do. So that would be that's going to be my recommendation for lab time today. Take this example for class, those who followed along, or the recording will be posted very, very shortly. Take these concepts and try to finish this out somehow. Well, there's the borders there, right? Left and right, up and down. So that you can just kind of essentially copy this logic for the other side. And then maybe add in another and condition so that and score is less than 5. So that once the score hits 5, the player no longer moves. We see the message, it stops moving. Or you could set playing to false, and as soon as the player gets there, shut it down. So the biggest one I'm thinking here, as far as what it would take to kind of finish this, is there's nothing here to stop the player from collecting coins. So that's my suggestion for lab time. See if you can turn this into, obviously not a masterpiece, but enough that we could start to call it a game. We're restricted to this play space, this space of possibility, as the vocab term I think our textbook uses. What we can have restricted to that. Stop the game when the victory happens. When we've won the game, stop the game. And using collisions and your own creativity, see what you can come up with to stop the player from collecting coins. Right, right now, there's nothing to prevent the character from collecting as many coins as they want. So maybe you could put some black circles around here and call them holes, so that when the player collides with them, the character disappears, like they fell down the hole. And then the coins randomly fluctuate around that. Or you could put in walls where the player has to navigate through like a maze to find the different coins. So then instead of random, there's preset spawn locations for those coins to show up, and the character has to navigate through a maze to find it. But something to make it fun to collect the coins, a challenge along the way. That's my recommendation for lab day today. Take this example and apply your own creativity, and those last little finishing touches, we need to make something happen. And yeah, it can be a lot of fun doing this. So see what you can come up with. Would y'all like me to open a new discussion board where you can share stuff like that? Whenever we have a class example that's like not quite finished, and I'm like, okay, my suggestion for lab time is running your creativity. Would you all like me to put a spot where you can share those with your classmates?
Sure, I don't see why not.
Okay, so I will open up a discussion board. Otherwise, that was what I had in mind for today. And then this example here is what we're gonna lead into the next subject. Because if we look at this to finish up today, it's sort of a segue into what we're gonna cover Monday. The main object for the game has an X and a Y, a speed that it moves at, the image, and then the bounds, and then the bounds have an X and a Y. Then the other important thing for our game, it has an X and a Y, then the image, then the bounds, and once again, the bounds have an X and a Y. So those are almost identical, right? And if we add more objects to it, they're going to have the same things. They're going to have an X and a Y. You have an image to represent them, some bounds, and then those bounds are going to have an X and a Y coordinate. So every time we add an object to the game, it's going to be essentially exactly that. We'll just be renaming our variables to keep track of what's what, but those same steps. So it sure would be nice if we could generalize that, right? And then have some just generalized generic code that we could just ask for that has all of this stuff. An X and a Y, a speed if necessary, because this doesn't have a speed, which really means its speed is 0. We could put coin speed equals 0 and say to move every time, and it just wouldn't, it would do exactly the same thing. So that would be part of the generic object. Then the bounds and all that. So that's what we're going to see on Monday. The generic version of this, so that if we need a game object, it already has all that stuff we need, and we just ask for an instance of the game object and pass in the particular the data for that one. Pass in what's different. So like in this case, we just say, okay, we need a game object at 234 with a speed of 3 in this image. Or in this case, for the coin, we'd say, okay, we need a game object that some random integer for the coordinates, the coin image, and the coin image. And then it would spit out both of those. It would do all this stuff that's consistent everywhere. Or for any other game objects we add, like I suggested, a hole might be a good way to add the first level of challenge to that game we just created. Any questions about this? Okay, so as always, it's an active subject. We learn by doing. So it's time to do in our scheduled slot. It looks like there's about an hour and a half to go actively give this a try. I will add some comments in there on the new stuff and send that out shortly. Worst case, it'll be this later. That'll be sent out later this evening after my 6 to 9:50 class. But it'll be sent out as soon as I get some comments added in. I will post this video as soon as Zoom renders it down and tells me it's ready the link's ready. Otherwise, I will be sitting here. I'm gonna keep my video set up here in place until 4:50. Text messages and Ivy Learn messages make noise on my phone. I can jump back on a Zoom call in a couple seconds time to address any questions that come up, but give that a try. See if you can finish out that game and use collisions to add something that would stop the player from collecting coins, and then those bounds and whatever you think would make a minimum finished game. And I'll go set up a discussion board where if you're really happy with what you made, you can share it with your classmates. And y'all can compare notes and talk about it. The part that's missing in the virtual environment from the face-to-face class, where we're all in the same room at the same time and walking down the halls to and from the parking lot at the same time. So otherwise, I will see you all on Monday. Everybody have a great weekend.
All right, you have a good one, Chris.